In treatment plant simulation, usually we are concerned with applying realistic diurnal influent flow patterns characteristic of the particular plant. Also, we likely are interested in knowing about the extent and seasonal nature of excess I&I flows, in addition to the diurnal municipal flow. Extracting this information from historical SCADA influent flow data, for example, measurements at, say, 15-minute or 1-hour intervals, is a very tedious and time-consuming exercise. BioTwin includes a very powerful tool for analyzing historical SCADA flow data to set up dry weather diurnal patterns for the 7 days of the week, seasonal variations in I&I, and the nature of excess flow inputs during storm events. So if you can access a couple of years of, say, hourly influent flow data, you can do all of this in a few minutes. Let's see how it's done with the BioTwin Flow Analyzer by following along with a demonstration of its capabilities.
I'm going to, navigate it to BioTwin login page, and I'm going to log in. And I think I cleared my cache, so I need to enter my details again. The flow analysis result can be saved as a flow analysis file, a.fwt, and you can open that alongside whatever other file you want to open it in. So it's not tied to a particular BioTwin configuration or BioTwin .bwt file. All right, so the first step to use the flow analysis tool, which is over here, Flow Analyzer. Now you can use this tool regardless of whether you have a configuration being built or not. So you will click on Flow Analyzer, and you'll see right now it's blank, right? Now, before you add a flow analysis, you need to have data imported, right? So before I do anything in flow analysis, I first want to bring in data into BioTwin. And the way I do that is with the data management portal. So I would click on this data tab on the left, and I would say add table, click once and add table. And this is the default name it gives it. I'm going to call it, let's call it plant XYZ flow data, right? And once I've named it what I want, I will then go to my data source, which in this case is an Excel, right? So if I go to the Excel file and I bring this into my data tab, so I do that by selecting the date-time column and the column containing the flows. I can select the other columns as well, and you'll see why, because it's going to ask me to choose which of these columns is actually the flow column, right? So let's say you have a data source with not only flow, but other data as well. It could be concentrations, right, or loads. But in this case, we have other columns called min value, max value. So if I just select those columns and go all the way to the bottom and press Control C on my keyboard, to copy it to my clipboard, and I then navigate back to this empty data table that I've just added in BioTwin, and I click on the 3 dots and I say import from clipboard. Now, if you have a browser that you've just cleared the cache, and so it's a fresh session when you've logged in, I would again need to allow data to be transferred from my clipboard to my browser, and I do that by clicking on allow, and that's just something controlled by your browser. So then it pops up the import wizard, and it's a rudimentary view, basically like a raw text view of the data that was on your clipboard. And most of the times you don't need to do anything if it's coming from your clipboard at this stage, because it is tab separated by default. But if for some reason or another the columns were separated by spaces or commas, you could use specify a different delimiter, right? But in this case, we're going to just click on next, and you can choose which row should be your title row and which row your data starts in, and you do that by toggling these these spin boxes. But by default, we've selected all the data such that our first row was our title, contains our titles, our headings, and our second row contains our data. So we don't need to change these. But if I wanted my data to start in, say, row 3, I would simply press the plus button, increase it to 3, right? And then I would click on Next. And the final step is it looks at the datetime format. Now, this is a nice, easy datetime format with no ambiguity. So if I, click on this drop down, it detects that one of two formats are possible with what it sees. And we're going to choose this one, the 24-hour clock, because we know it's a 24-hour clock being used in these daytime stamps. The next thing you want to do is identify the time zone of this data source. So let's say this data was coming from a plant in London, right, in the UK. There would be periods in time where you have daylight savings on and off, right? So sometimes you would have timestamps where it would jump from, say, I think it would go from 12 a.m. straight to 2 a.m., for example, right? Or you would have duplications in timestamps, like you would have 1:30 a.m., then again 1 a.m., 1:30 a.m. And that's why it asks you to identify the time zone so that it can handle those situations accordingly. If you get it wrong, it doesn't matter. It's robust enough to tell you that there was something that didn't make sense, and it's applied the necessary correction. So in this case, let's say which city was this data from? And it's also important to do that because we want diurnal peaks to be at the hour that they should be, right? So once you've selected your time zone, and by default the time is in data column number 1, because whenever I copy data into BioTwin, I always have the date time as the first column, just because it makes your life easier. So everything's okay, and once I'm happy, I click on OK, and it's going to upload it to the cloud, and then it's going to download a preview of that data into your data management portal. Now, this one contains just over 35,000 rows, so it's a fair amount of data, because it's at a 15-minute interval. So you should expect, when dealing with that amount of data, for it to take about a minute or so for it to process the data and then display the preview of that data. And you can see the status indicated on the top here in the actual data section. So where I identified or specified the table name, on the right-hand side of that, it's giving me a status that is specific to this table, right? So, we have a status at the top that is specific to building files and simulating files. And then we also have a status that is specific to the data import exercise, right? So once the data is processed and downloaded, you'll see this status will disappear. So, and depending on your internet speed as well, that will impact how long this takes. So you'd like to have a reliable internet connection when doing things like this, right? And it's also worth saying, and I can show you that as well at some point, maybe not today, but whilst this is going on, you could go back to your plant tab and continue building your file, right? And defining properties of your elements, building your configuration, whilst you are having that data import being processed. And you can also run a simulation whilst that data request is being processed. all that's going to happen is if I, say, for example, run a steady state simulation. Now I haven't defined, I just dropped these on the board. So it's telling me I haven't specified any data for these elements, which is fine. This is just a demonstration. I'm going to say accept. And then it goes on and runs a steady state. If I go back to the data, you can see how it was doing very quickly because it was quite fast. But it was doing both things at the same time. It was processing my data request, and it still fulfilled the simulation request with the engine. So it's quite nice in that, you're not limited to sitting here waiting and being restricted to do other things whilst this is happening. Because it wouldn't be a good user experience if you had to wait for a minute before you could do anything else. So you can see here it's finally come in and it's downloaded the first page of that data set. So by default, it splits it into pages with 24 rows, right? Because usually you have an hour interval in your data set, so 24 hours, 1 day worth of data being shown on each page. And once you've imported it, you see on the bottom right-hand corner, there's this triangle where we put all of our warnings or any information that a user should be aware of when doing certain things in BioTwin. And if I click on this triangle, you'll see it is giving me some information about the time zones. Right now, we were uncertain about the time zone a little bit, and it says that there was a timestamp of 2025 0309 2 a.m. being specified in the data set that was imported, right? But our API is smart enough to know that this time that we have specified does not align with the time zone specified. And what that means is, in this time zone specified, there's a period of daylight transition into or out of daylight savings that results in this timestamp not existing, right? So because of daylight savings, in this particular time zone, you would actually never see this time on a clock because of the clock either jumping forwards or backwards, right? And you can see that it says that it's determined that the correct timestamp should have actually been 2025 0309 3 a.m. right? So these are very useful warnings to notify the user that there was some correction to this timestamps being applied by our API. And that's nice because we'd rather take care of it for you than have you scan through thousands of lines of timestamps in Excel to comb it out yourself. Because what happens is, sometimes you get data that has gaps or has duplicates due to daylight savings, and that data gets manipulated to fill those gaps, even if those gaps use timestamps that would never actually exist on a clock for that particular time zone. All right, so now that the data is actually in BioTwin, we can start doing things with it. So to go and use it in a flow analysis exercise, you would then go onto your flow analyzer tab, and you would click on add flow analysis, right? And you can add several flow analyses by continuing to click on add flow analysis, but for now we're just going to add one. And like with the tables, you can give this specific flow analysis a particular name. So let's call it flow analysis plant XYZ, and let's just use a generic name, setting 1, because I'm going to apply a particular setting that is unique to this flow analysis. And you'll see why I'm doing that later on. But let's just give it a unique name. And then we can start with the flow analysis by working from the left-hand side all the way to the right-hand side through these icons shown at the top over here. So you see on the left it says Start Analysis here, and it's showing you the data stack icon, right? And currently the data stack icon is the only one that is not grayed out. So it's indicating to you that it's the only option that is currently active to you right now, because before you can use any of these others, you have to do this step first, right? And you work from left to right. So we're first going to click on this icon, and once that operation is complete, we'll be able to click on the subsequent icon. Okay, so you click on that icon to choose your data set, and it pops up this window where you have the available data sets being listed on the left-hand side. So I only have one, which was manually imported from Excel, and that's why it shows manual import and plant XYZ flow data below it. I could have several tables that I could choose from over here, right? I could also have data from SCADA, which would have a second main menu called SCADA import, which I would then expand. But for now, we're just going to use our manual import. So I would first click on plant XYZ flow data to choose my data set. And then I identify the flow column that I actually want to use for this flow analysis, right? And our flow column in this example is called mean value MGD, because that's what you were provided by the plant. And we just added the unit, the string MGD to identify the unit so that we could remember. And once you've selected the flow column, you would click on OK. It then brings up this form showing the configuration settings for this flow analysis. And the first section at the top here shows you the flow units that are being used. So in our case, it's MGD, right? So we choose MGD. There's also the option to try and attenuate noisy flow data, which results from, say, data from a pump station or a wet well. If you have data from a wet well, where if you look at the raw data, it just goes up and down, and it doesn't actually look like any diurnal pattern. You know, let's say you see no typical diurnal trend in the raw data, then what you could do is check this box to identify it as being pump data from, say, a wet well, and that just makes it more likely for you to discern a diurnal pattern from that data set. So there's some smarts built into the API to take care of those scenarios. For now, this isn't a pump data set, I don't think. I mean, we'll see. But I'm going to leave it unchecked. The next section in the settings refers to what we call auto trim. Now, in the process of this exercise, when it's identifying the diurnal patterns for the dry weather periods, you have the option to have it automatically remove outliers in those diurnal trends. So if it's evaluating all the Mondays in your dry weather data period, or all the Tuesdays in your dry weather data period, right, each day of the week, if it sees a diurnal trend for a particular Monday that lies outside of the average of all the other Mondays, it will automatically remove that trend if this box is checked. And it would do that for each day of the week. And doing this could reduce the amount of time you need to spend to clean those data sets up. Right? But for now, we'll leave it unchecked. And then finally, the last section over here has to do with the time interval. It's identified that the time interval in this data set is smaller than 1 hour, right? So if, say, you wanted to only work with an hourly interval in your flow analysis, you have the option to compress that 15-minute interval into an hourly interval by checking this box, right? So let's check this box, because ours is 15 minutes. If we compress it to 1 hour, it might speed things up a little bit. Okay. So once I'm happy with the settings, I will click on OK. And once I've done that, you see I have a status again showing for this specific flow analysis, telling me that it is now downloading the flow data from that table in the cloud, which I've specified. And it's also going to do a light scrub of that data so that it is suitable for a flow analysis. Things like removing negative values and so on, right? So, and again, depending on the size of the data set, it could take a minute or two. And but again, whilst this is happening, you could carry on building your configuration or running simulations, right? Because the flow analysis exercise is an independent exercise and independent of, say, your BioTwin model. It's only at the end when you actually export the data of the flow analysis into your model that it becomes relevant. But even then, once that export of information is done, that link between the flow analysis and your model it's not a permanent link. It's severed as soon as the data is sent, so you don't have to worry about impacting your BioTwin model if you're doing something different to your flow analysis. Okay, so this is the lightly scrubbed data set that it's downloaded from that table you've specified. And if I zoom in on this data set, you'll see, if I hover my tooltip over it, you'll see there's no longer a 15-minute data interval. It's now hourly, right? So it's now hourly because we chose the compressed to hourly setting. So I'll just say reset zoom to get that data back. And the next step that we do in this exercise is the second icon from the left. And you'll notice this icon has now become active. Before it was grayed out, but now it is black to indicate that it is active. And if you hover your cursor over it, it gives you a hint telling you what that icon is going to be used for. So this icon, we're going to click on it to calculate our daily average flows. Right? So I click on once on that icon, and a window pops up asking me to identify the minimum and maximum flows that I want to allow when screening this data and using it in the flow analysis. So let's say this chart on the left here, let's say we have this very odd spike of data going down all the way to 0, right? And it's clearly an outlier. We don't want to deal with 0 flows. Well, then all we do is we specify a minimum flow of, let's say, for example, this value of 25, right? You see we have one line going below 25. Let's pretend that that's an outlier, right? So let's say realistically we don't expect anything lower than, say, 30. Anything lower than 30, treat that as an outlier. And that means that I will simply enter 30 into this minimum flow box. And you can also do the same for maximum flow, right? But there doesn't appear to be any maximum outlier flow for us in this data set, so we'll leave it at the default that's being calculated. And what it's going to do is any flow that is below 30 mgd, it's simply going to replace it with a flow of 30 mgd. And once you're happy with those settings, you click on OK. And again, once you've clicked on OK, you'll see very briefly that it was calculating the request, and it was downloading the daily data, daily average flows that it had calculated. And once that's downloaded, it creates these two charts for you. One called daily average flows. So this is a chart showing you the daily average flow for each day in your data set. and you can see it's shown at 12 a.m. on each day. And the other one is a probability plot. So it's essentially the percentile plot of the average daily flows from 0 to 100, as well as the minimum and maximum flow for each of those percentiles, right? So, for instance, if we go to the 50th percentile, the average daily flow for the 50th percentile was 97.86 mgd. The maximum flow for the daily flow for that day was 116, and the minimum flow for that day was 62.35, right? So it's really powerful. Definitely from, whether it's a 30% design or 50% design, it's really useful in determining which flows you should be designing a plant for. Because you wouldn't want to design a plant for, say, your 100th percentile, which is not going to happen very often. You'd probably design it, depending on the standard, but something like, say, your 70th percentile, and have enough capacity to handle the surges in the flows of most. Okay, so once you've done the daily average flow component of the analysis, you can see the next icon has become active, and if I hover my cursor over it, it now shows me that I can click on this icon to extract the diurnal patterns for this data set, right? When you click on it, it pops up a window where you're going to create your dry weather diurnal trends, right? Now, for this particular data set, we have you can see there's a period in this data set where the baseline of this data set shifts upwards just a little bit and then comes back down, right? The intention of this part of the analysis is to identify that baseline dry weather band, right? So the goal here is to specify a minimum flow that we determine by looking at this chart, as well as a flow multiplier factor, a peak flow factor, to determine the maximum dry weather flow. What we can see here is there's actually quite a long period where we have what may look like a decent amount of infiltration. Okay, so that dry season period, we want to try and capture, let's say, the baseline dry weather flows with this band that we have over here. So we do that by manipulating the minimum value and the flow multiplier. So the minimum value, I think, is pretty spot on, because I'm getting these flows, I'm also getting the baseline in this period. I mean, I can maybe bump it up to, let's say, 67, and it's going to update in real time, right? So whenever you change the value here, it's going to update this band. I can increase the flow multiplier for the dry weather period a little bit. Let's make it 1.17. Maybe a little bit more, 1.18. Right, so now I'm getting that bit. I'm getting this as well. So, right, so let's try that as a first pass, because you can always redo this step if you're unhappy with the result or you think it needs to be refined, without having to start from scratch. And another thing you want to achieve here is you want to try and have the number of days counted within that band. You want to try and have them be more or less the same for each day of the week. So you'd want to have more or less the same amount of Mondays as you do Tuesdays and as you do Wednesdays and so on. You don't want to end up with a setting that gives you, say, 3 Mondays and 10 Sundays and 10 Fridays and 20 Tuesdays, right? That would result in some days having good diurnal trend predictions and other days having very poor diurnal trend predictions. So you want to have a consistent number of days for each day of the week for a full 7-day period, from Monday to Sunday. So once you're happy with your minimum flow and your multiplier, you would click on Extract Dry Weather Diurnal Profiles. So I click on that button, and what it's going to do now, and it did it quite quickly, this graph on the right here is the diurnal trend for all the Mondays that fell within this band, right? If I click on Tuesday, these are the diurnal trends for all the Tuesdays that fell within this diurnal band, and so on and so on, right? It will provide these sets of diurnal trends for each day of the week from Monday to Sunday. Now you can see when I was clicking on them, some of them looked like they were a little wonky, right? It looked like they weren't really an accurate representation of a typical Saturday or a typical Friday. If I go back to, say, the Saturday, this one over here, for instance, looks like an outlier, right? Something happened here which was different to all of the other Saturdays. I don't want it distorting the rest of the Saturday trends, so I want to remove it. Now, you can remove that trend in two ways. You can either hover over the series and to the point where you have a little circle appear on the marker. And when you do that, you can click once, and that series will be hidden, right? And when I did that, you now see that series in the legend, it has a line drawn through it, because that series is no longer being considered. It's now hidden from the rest of the profiles. If I wanted to bring it back, I would simply click on that series in the legend again just once, and it comes back. And in the same way, you could have removed it at the beginning as well. You did not necessarily have to click on the series to remove it. You could have gone to the legend directly and clicked on the series in the legend as well to remove it for consideration. And you would proceed to clean up the trends for each day of the week in this manner, right? So here's another one, for instance. I'm not happy with that. It's going to distort things, so I'm going to click on it to delete it. And that was for the Friday. And essentially this exercise of cleaning it up, this would be made shorter had I checked auto trim at the beginning. All right, so I'm not gonna worry about cleaning up all of these, but you get the idea. I mean, I suppose I could just, it looks like just the Friday that maybe needs a bit of cleaning, so I'll take out that one, and I'll take out that one. You don't want to remove too many because you still want to have more or less the same number of days for each day of the week. Saturday looks fine. Sunday looks fine. Okay, so once you're happy with the data sets for each day of the week, you would then click on OK, and it would then go off and do two things. It would first calculate the dry weather trend, diurnal trend for you, and it will calculate the excess flow trend for you. And once it's done that, it produces these graphs under the DWF diurnal patterns group, as well as these graphs under the I&I daily averages and detailed data group. Now, I'm going to run through what each of these are, but the dry weather flow diurnal patterns group contains two charts. It contains the diurnal trend of the Monday, Tuesday, Wednesday, all the way through to Sunday. And what this is the Monday diurnal trend, for example, is the average diurnal trend when considering all of the Monday diurnal profiles which you had kept in your dry weather analysis that we were just doing. So it looked at all the Monday diurnal trends that we were happy with, that we did not remove, and it calculated a Monday trend using all of those diurnal patterns. It did the same for the Tuesday, the Wednesday, and the Thursday, and so on. subsequently producing a diurnal trend, 24-hour trend for each day of the week. And what it also does is it calculates an average weekday diurnal trend and an average weekend diurnal trend. Now, you usually see a shift between the weekend trend and the weekday trend because people get up later on the weekend, right? And if we compare the weekday trend versus the weekend trend, you can see that the peak flow for the weekend happens a lot later. Now, to me, this data it doesn't look typical in the sense that you expect to see, say, it starts slow and then it peaks, goes down, and peaks again and goes down. That's not what this trend looks like. So perhaps pumped data or pumping station is influencing this flow analysis. But I can show you the next feature if that is the case. And what we then see under the I&I section of the flow analysis is essentially a calculation of our excess flows, our infiltration and inflow. So what it also calculates is, on top of the dry weather flow that it calculates, it also calculates the excess flow by difference of the total flow and your dry weather flow, right? So our excess flow is this I&I, our infiltration and inflow. And within that infiltration and inflow, we obviously have two components, one being inflow and one being infiltration. So what we also show in this trend is the infiltration series. And the infiltration, really, you can think of it as, say, a trend that's tracking the bottom of the excess flow line. So if I click on infiltration, and just to hide it, if I were to trace a line on the bottom of this II trend, that indicates to some degree the trend of your infiltration flow. Now, obviously, it's a subjective analysis, but it is just one of the ways that people have estimated I&I and infiltration in the past. And this trend, you can see, is a daily trend. Right? So it looks at the I&I and infiltration on a daily basis. We also have that calculation done on an hourly basis. So this trend at the bottom here is really just an hourly version of the one above, which is your daily average trend. Whereas this one over here, this is your hourly trend of I&I and infiltration. Okay, and once you've done a flow analysis, you might also see some notifications. And for instance, if I click on this triangle, it's telling me that when I did the dry weather analysis, there were 2 dates that did not contain 24 samples. And that could have been, for instance, due to daylight savings. To me, it is possible that one of these days definitely were due to daylight savings, because this one is in November, this one's October. But the point being, if it sees days which do not contain 24 samples, it removes them for consideration in the dry diurnal trend analysis. Because we want to have 24 samples over the day to create to have that data set influence the diurnal dry weather trend. So I'm just going to say clear all to close them, and that makes the warnings go away. Now, like I said, you can execute or redo certain steps of this flow analysis without having to start from the beginning, right? So let's say I wanted to do something different in terms of my selection or cleanup of my dry weather trends. Well, I can do that simply by clicking on this icon to extract the diurnal patterns and run through the same motions as I did before. I can also, say, go back to this step where I calculate the daily averages. Maybe I wasn't happy with the minimum and maximums that I had specified, and I want to try something different. well, I can do that too. And if you obviously choose a different data source, well, then you will have to do all steps again, because I went and changed something right at the very beginning of the flow analysis. So let's say, let's do this analysis again, but let's use pump data because I want to see if it makes a difference. So if I click on add flow analysis again, and I'm just going to call it flow analysis plant XYZ setting 2, right? And I go to my data stack to load the flow data. I'm going to choose the same data as before. We're not changing anything there. And the units for MGD. I'm going to do two things this time. I'm going to say apply the pump flow setting to try and see if we get a more normal looking diurnal pattern for our dry weather flows. And I'm also going to apply auto trim. And when I choose the pump flow setting, by default, it's going to resolve that data to an hourly interval. So I don't actually have to worry about compressing it anymore. So I'm just going to choose pump flow and auto trim and click on OK. You can still, you can see when I have over these charts, I still get my tooltip. I can make the left or right hand side of this analysis smaller or larger by dragging this divider, right? Which is also nice. So if we go to the next step where we calculate the daily average flows, I'm not going to change the minimum or maximum here. I'm just going to leave it at default this time. Say OK, and let it calculate the daily averages and probabilities. So, right now these are empty, and as soon as each of these sections get calculated, these sections expand with the calculation result. So as before, we get our daily average trend, and then we also get our flow probabilities. And the next thing we do is our diurnal trends by clicking on this icon. And I don't think we need to change. This one actually looks quite good. I mean, maybe I'll make it 68. 69, that'll be too high. Maybe not. Make it 69. 1.16. 7. I can't remember what we used before, but it doesn't matter. Let's just go with this. So let's go with this. Let's treat this band as our dry weather flow band. The band identifying our dry weather days, and say extract dry weather diurnal profiles. And let's see, maybe there's a difference using pump flow, maybe there's not. It depends on the frequency of the data. So here you can see, because I had auto trim activated for this particular flow analysis, you can see that without me clicking on anything, this series has already been hidden from the data set for consideration. If I click on it again, you can see it come back, and it obviously removed this one because this point it detected as an outlier when looking at all of the other trends, so it removed the whole set, right? So I'm just going to click on it again to take it away. So you can always check what it's removed and accept or not accept it. If I look at the other days, Tuesday it didn't remove anything. Wednesday there was one. If I bring it back, yeah, okay, you can see why it removed this particular Wednesday. I'll just hide it again. And anyway, you can check what it's removed for each of the days by just navigating through each of these tabs, right? And once you're happy with the selection, you will click on OK. Now, it doesn't look like the pump flow setting made much difference to this particular diurnal trend. Sometimes that's just the nature of the data and the plant that you're working with, right? it really depends at the end of the day, the catchment area and the plant and the infrastructure um, in place that will dictate what this trend looks like. But it's definitely flatter than your typical trend. And what is evident is that there's still at least a shift between the weekday and weekend period. And then again, you get your daily average trends and your INI data. So now let's say you wanted to save this analysis. To do that, you would simply go to File, Save, and then Save Flow Analysis. So if I click on that, you'll see it downloads a file. This one is called Untitled 2FWT, and that's because it's using the default file name for the flow analysis, which is specified over here at the top. So if I wanted to name it something specific, like let's say demo flow analysis, and then click anywhere else, it will automatically add the .fwt at the end of that. And if I again go to File, Save, Flow Analysis File, you'll see that now it's downloaded the same file, but this time it's given it the name of demo flow analysis.fwt, right? And what you can then do is you can open up that file in a different project. So let's say I go to plant and I want to close everything because I want to open up a different model file. So I'm just going to say File, Close All. And I say yes because I don't want to save it. I don't want to save this configuration. And it's going to clear the board. So because I say Close All, it's going to delete the plant configuration, and it's also going to delete the flow analysis, which I've already saved, right? But let's say I want to open up another BWT file now. So once it's loaded, and this you'll know that by these messages on the top, once it's loaded, I will be able to go to the flow analyzer and look at the flow analysis that was saved in this particular flow analysis file, right? So once it's loaded, it takes me to the flow analyzer, and I've only got one flow analysis in this flow analysis file. But if I had two flow analyses, then I would see two flow analyses under this tab. And you can see this flow analysis produced a trend which was, while still flat, it has it's a bit more normal in terms of the diurnal trend that we're used to seeing. You know, it has a peak just after the morning rush, and then it also has another peak when everyone gets home from work and starts cooking and showering. And we also see that shift between the weekday and weekend in that peak. It also has the daily INI trends as well as the hourly INI trends. And once you have a flow analysis done, or you open up an existing flow analysis, you can add these charts of the flow analysis to your viewer, and you would do that by clicking on this icon over here. So if I click on that icon, you will see it pops up a message saying that the viewer dashboard has been created, showing you the current results. So if I click on OK, and I go to viewer, you'll see it now has a new dashboard called BioTwin Flow Analysis 1 YRTP, because that's what I named the flow analysis that I'd done. So it adds a dashboard with the flow analysis charts, which I can then see nice and big on the screen. And when you save your BWT file, this dashboard, flow analysis dashboard, would be saved with the BWT file. This dashboard is separate from the flow analysis. Once you've created it, if you do something new in your flow analysis, if you redo a certain step in your flow analysis, you would have to add the charts to the dashboard a second time in order to get the most current charts. There is no live link between this dashboard in the viewer and the flow analysis over here. And we've been purposeful about that because it can become quite complicated when making changes in the flow analysis, and you now need to ensure that all those charts are updated. It's easier for a user to just add another dashboard if they've made changes to a flow analysis and simply deleting an old dashboard, right? And the last thing with the flow analysis is how we actually use these in the model, because this is great, right? It's nice to produce all these trends, super cool, but now what do we do with it? Right, so the final cherry on top of all of this is getting essentially two components of this result into your model. The one is the dry weather flow component, right? We want to get these dry weather trends into a dry weather influent element with associated concentrations. And we want to get the excess flow into our BioTwin model to represent our storm surges, which dilute our loads, right, to the plant. It's a hydraulic load on the system. So the way we do that is you would click on this icon that looks like an influent element, right? See, if I hover over it, it says create influent element with flow analysis data. So if I click on that, it presents me with two options. I can either create a dry weather diurnal influent pattern for influent element, or I can create what we call an excess flow element. And that excess flow element will contain the I&I flows, right? It will contain the infiltration plus the inflow component of the flow. So we're just going to create the dry weather input first. So you click on dry weather diurnal pattern to select the dry weather element. And you can either put that into one of two elements. You can put it into an influent COD element, or you can put it into an influent BOD element. I like COD because, well, that's what it should be if you ask me. But I know a lot of people in the industry still work with BOD. So that's why we have the option for an influent BOD element. And when you're defining your dry weather diurnal cycle, you can either define it as a 1-day pattern, or you can define it as a 7-day pattern, right? If you define it as a 1-day pattern, you obviously have to tell it which day from these diurnal trends you want to use for your typical 1-day pattern, right? So you could use either the average weekday, the average weekend, or a particular day of the week to define your 1-day pattern. Or you could use a 7-day trend. And by default, this particular project that we are working with, this particular configuration file that we are working with, it has a simulation start date of Monday, 13th May 2019, right? So it starts on a Monday. And what that means is when it creates the dry weather diurnal pattern, it's going to make sure that the first flow value comes from the 0 hour on Monday. If for some reason or another, I wanted the diurnal trend to start on a Tuesday, even though my simulation starts on a Monday, and it wouldn't make any sense to do this. But if you did want your diurnal trend to start on a different day of the week, let's say you want to use it for a different project, you want to save the influent file and use it on a different project, then you could change the day that this dry weather 7-day pattern starts by clicking on this radio button and simply using a date that falls on, say, a Tuesday, right? So you can tell it which day of the week you want your 7-day pattern to start. Because obviously that's important and it needs to relate to your simulation start date, right? I'm just going to use the default option. Our simulation start date for this project was Monday, so I want the dry weather 7-day pattern to start on a Monday, and then I'm going to click on OK. And once you click on OK, I don't know if you saw, but at the top right corner, there was a status updating elements notice. Because what it was doing is it was telling the engine in the back end that it has added an influent element to the configuration. And if you go back to the plant tab, you will see that now there's this second influent element that has been added to your configuration. It's obviously not connected to anything yet. You would have to do that. But if I now double click on this influent element and open up the properties window and scrutinize the variable pattern, you can see, boom, it's taken that 7-day diurnal trend and it has put it into an influent element, an influent COD element, and it has just applied typical default concentrations in the element, which you can then overwrite with whatever concentrations you feel appropriate for your dry weather influent, right? And once you're happy with that, you would just click on close, say OK, you see it updates the project, and once it's done that, you can connect it up to your plant and you can simulate with it. Now, we can also do the same thing with our excess flow. If I go back to the flow analyzer and I click on this influent element again, and now I want to create an excess flow element. What this is going to do is it's going to create a state variable influent element with the excess flows that were calculated between the dates that I specify here. Now, I'm going to keep it very small so that it doesn't take a long time to generate this element. But obviously, if you have tens of thousands of rows of data in your excess flow itinerary, it will take a bit of time to create this element. But for the purposes of this demonstration, I'm just going to keep this very short. And let's go from 13th of May to end of May, right? Because let's say there's a particular surge event, storm event, that you are interested in and want to know how it's going to impact your plant performance. Well, you could do that, select that period by simply specifying the start and end date of that particular storm surge. And once you've done that, you would click on OK. It again goes off. It creates that element, updates the configuration in the engine. I go back to the plant tab, and here is my excess flow element. And if I double click on that and I scrutinize the pattern, you can see on some days, some hours, the flow is 0, and on other hours, the flow is not 0. And by default, with this element, all the concentrations of the state variables are 0 except the I and I. So by default, we just put a little bit of I and I into this state variable element representing the storm flow, because that is usually what you see in storm flows. There's a surge of inerts that come, but not much else. It actually dilutes the COD and N and P loads coming into the plant, right? And this is why it's so useful generating these two elements, because now after the flow analysis, we have a nicely defined dry weather influent component and a nicely defined excess flow influent element. And you can do everything you did before with influent elements, like change the wastewater fractionation for this component. And like with your other influent elements, if I change the FUP to 0.2 and say OK, I go to my specifier, you will see it has automatically added the influent specification for the dry weather element that we added from the flow analysis. And it still preserves that two-way link between the fractionation I specify here and the fractionation that is shown for this element in the plant. So that last beep in the flow analysis was the last hurdle that we needed to implement in our platform for it to become a truly powerful tool.